All right, gang. Today is the first part of our review for our final exam. All it's going to be is everything that we've done from the day we started until about midterm. Next week, we're going to go over the rest of the information, but today is going to be machine setup, our 8 commandments, PPE, things of that nature. This is all the first things that we did in the class. Any questions before we get going? How about when is our exam going to be? Last day of class. What is that going to be? Thursday. Next week, Thursday. So a week from today. That day, we are just going to come in and take the exam. When you're done, we're going to go out and clean, and we're out. Okay? One thing I don't want you to do is get too hung up on, oh my God, I'm taking a test. We're going to take this test, and I'm stressed out. Don't worry about what's coming up. Worry about what's going to happen today. We're going to go over the test today. Take notes. Study your notes. Once we're out of here, get out in the lab, work on your assignments. Okay? Hey, this semester, what did you guys learn? Lay some stuff on me. How to weld. That's fantastic. What else? What else about how to weld? How to set the machine up. Good. What else? How to fix the machine. Perfect. You can be the best welder on the planet, but if you have a malfunction with the machine, you got to go get your supervisor, hey, my thing doesn't work. They're going to look at you like, what you spend all the time in school for? Good. What else? Safety. Safety on using the machine. Good. How to use the shear. Scott, you got anything for me? How to fix yourself. Good. That's going to get into the 8 commandments, right? You guys remember what the 8 commandments were? You're not going to give them to me now, we're going to talk about them later. So we have those 8 things that we look for, and as long as you know what each one of those 8 things do, that will fix most discontinuities or defects. Anything else out there? What else we got? I got a little cheat sheet here, some notes. Parts of the machine, we talked about that, machine setup. What about metal transfer? What did we learn this semester about metal transfer? 3 different types. Doreen, let me hear one.
Spray.
Spray. You sound horrible. You okay?
Sorry.
Okay. As long as we're okay. Chris, give me another one.
Short circuit.
Short circuit. Tom, give me one more.
Globular.
Good. Globular. I'm not going to make you explain them right now, but you are going to need to be able to explain them on the exam. Okay. What about polarity? What have we learned about polarity? How many different types of polarity do we have on our machines? 2. We have positive and negative. What do we call them now? DCEP. That's DCEN. So DCEP, DCEN. So electronegative, electropositive. And that's what do I have on this one. What about discontinuities? The first few discontinuities that we talked about. What did we discuss? This is the beginning of the semester. Overlap, which is what? And what does it look like?
Oh, it's kind of like circular shape over metal. Not really getting in there.
Okay, I'm liking that. What else? My definition, my specific definition. My specific definition for overlap. Might be ropey. It's something about the face and the toe. Anybody? Katie's feverishly going through her nose. Okay, we're counting down. Okay, it's where the face of the weld overlaps the toe. Okay? What else did we talk about discontinuities? Undercut. What's undercut?
Filler metal doesn't fully reach the top plane, there's a gouge.
Okay, there's a gouge in the base material. That's what I'm looking for. When I ask you to define undercut, I'm looking for a gouge in the base material. What's our last one? You gave it to me. What do you got? Porosity. What's porosity? It's some gas inside the weld material. Comes out as air pockets in the weld. Some little holes in the weld. But you guys didn't tell me that we had this stuff popping up on my computer. You're supposed to be watching out for me. There we go. Okay, safety. What PPE do we need to use? I'm going to put this up on the board. Let's start from head, go down to our toes. Safety glasses. What else? Remember, head to toe. I hope you're a little better than 5 shade. Well, let's just go with welding helmet. We don't have to. Welding helmet, at least a 9 shade. What else do we need so we don't get my hairline? Welding cap would be good. Something to cover your head up. Those sparks, especially all of y'all that are doing vertical ups. Yeah, welding cap, that's good. All those sparks come down, burn your hair, burn your head. Put something on there. Okay, now what?
Welding jacket.
Welding jacket. Welding gloves. Now with your welding gloves, what kind of material? Should be leather or heavy cotton. What don't we want for welding gloves or any other welding attire?
Synthetic materials.
Synthetic materials. What happens if we have synthetic materials?
They melt.
They can melt. If it melts, sticks to your skin, when we take that off, the skin's probably coming wet. Okay. What else? Wear pants. When you're in my welding lab, please wear pants. Okay? No spandex shorts, no none of that stuff. Wear some pants. What kind of pants should we wear? Wear some jeans. No frayed. No Bon Jovi pants. Okay, what else? Steel toe boots. Perfect. There's a couple other things that we talked about the first day with PPE. One was with pockets, the other one was cuffs in your pants. What do we need to know about that?
Pockets and cuffs.
If you can have pockets, just make sure you get the turn down where they're snapped together or buttoned down. You don't want sparks getting in your shirt. And it's going to get your attention. It's going to make you feel alive. What about cuffs in your pants? What's that? You cuff them to the inside. How come? Yep. Because next thing you know, you're on fire. You're running around like Ricky Bobby. I'm on fire. Pants are on fire. Not a good scene. What about shop safety? What do we need to watch out for in the shop? What is everything in the shop? Everything you go up to touch, what is it? It's hot. Good. What else? It's hot. If it's sheared, it can be sharp. So, out of our PPE, what do we need to wear? What about checking to see if something is hot before you just go up and grab it? Oh, I need this. Good. Put your hand over it, see if it's warm. Gingerly touch it. Just don't go up and grab it. If it's something that was freshly welded and you go up and grab it, before you know it's hot, it's too late. Okay. What's that? What? That'll take some skin off too. No good. Anything else in the shop? Does general shop safety? Don't run. Good. If you run and your big instructor's coming around the corner, nobody in here is going to take me down. Scott might have a chance. You run into me, we're going to have an issue. If you come running out with a hot piece, or somebody else is running up in the aisle, and you come out of the booth and you have a hot piece, bad things can happen. Use some common sense. What else? No messing around. Good. One thing with messing around, you may just be joking, but all it takes is one move, one comment, now it's serious. And once again, I got to get involved, and that's going to be bad. No good. Anything else in the shop?
Keep the floor clean.
What's that?
Keep the floor clean.
Keep the floor clean. Keep all your stuff swept up. If it's stick welding, you got little rod stubs on the floor, you got enough of them, now you got to ski anywhere. You step on that stuff, you're sliding all over the place. Same thing with wire. We have a bunch of wire on the floor, what do we do with it? Pick it up, wrap it up, throw it away. How come? You can get sucked into the machine, what else? Trip over. Good. Anything else? Good. It's a perfect transition into specific equipment. On the shear, he said make sure you yell clear before you cut a piece. That way people behind the shear are alerted that you're working on it. If somebody's back there and the machine's on, they shouldn't be back there to begin with, but you're better off yelling out clear to make sure no one's back there, because if it comes down, it hurts somebody pretty bad. What else on the shear? How about non-human safety? Safety for the shear.
When you're done with the drop the blade.
Bring the blade down, good. That way there's no stress on the hydraulics. Tom, what else? What about the blade?
Before you cut the blade, make sure you have it at the proper gauge setting on the machine.
Good. The blade gap. Make sure the blade gap is set correctly. If it's too wide, what happens? You get a big burr, or what else? It might not even cut. It could jam up. It might just roll that piece over and work like a brake press and fold the piece over instead of actually cutting. What happens if it's too tight? It can get jammed. It can damage the blade. What other equipment? I think we're pretty good on the shear. Oh, no, hold on. No. Take that back. On the shear, what about getting your hands out of there? The shear doesn't know if it's your fingers, a piece of steel, whatever. It's going to come down and get you. Keep your hands out of there. Keep your fingers off from underneath the clamp. Those come down with tons and tons and tons of pressure. And it may be tough, but if that spring comes down with tons of pressure, it's going to pop your finger like a zip. Yeah. Pretty cool, huh? Okay, now I think we're done with the shear. Anything else on the shear? We talked about gloves and sharp edges. When we cut on the shear, the pieces are going to have sharp edges. Other than that, I think we're good. Don't stack the sheets. Good. Always cut side by side. Anything else? I'm trying to transition out of here, but you guys keep throwing good stuff at me. What do we got? Nothing? No? Going once? Twice? That's your final answer? Okay. What else? What are you guys talking about over here? Yeah, there's a light curtain where if you get beyond that light curtain, it should not work. But don't always take that as fail-safe. What else in the shop do we have to discuss safety for?
Your grinding, you need ear protection.
And the grinding? Good. Ear protection, face shield. What else?
Safety glasses.
Should have safety glasses. How come?
Well, the sparks can easily get underneath the face shield.
Sparks can get underneath the face shield. Why do you have to have a face shield and the glasses? Pieces of metal that come off, or if that wheel blows up, you don't want to take that to the face. Like I told you before, I haven't stayed this good looking for all these years by not wearing my PPE. Always wear your PPE in there, especially in the grinding room, because if one of those wheels blows up, some of those wheels are turning 5,000 to 10,000 RPMs. It blows up, there's a lot of inertia, and it's like a grenade, it's shrapnel, that stuff comes flying off of there. What else for grinding?
Or your sparks so they go into the machine.
Good. Have the sparks going away from you, preferably away from anybody else. We got ear protection. It gets loud in there. Are we supposed to be smoking this material that we're grinding out in there? No. So what can we use for that? Turn the vents on. What can we have on us? Respirator, mask, something to filter out some of those particulates. Okay, are we good on the grinder?
Make sure you have firm grasp on your tool.
Hey, hang on to that thing. Hang on to it. It's gonna be like a wild animal if you turn it loose. Anything else? Make sure the safety stuff's on there, the guard. Make sure it has a guard on it. Coming towards the end of the grinder. Everybody have anything else to add to the grinder? Matt, give me something new. What about what we're doing with the AWS stuff?
Shielding gas?
Are we going to put those levels on there? For
Oh.
the AWS?
For the torch?
The torch.
Don't burn yourself.
Burn yourself. The flame's about 7,000 to 9,000 degrees. I think it's pretty hot.
5 psi for propylene and 20 for oxygen. Make sure the tanks are chained up. And before you take the valve cover off.
Okay, you did it on almost all of them. We're looking at about 5 to 7 psi for fuel gas, especially acetylene. Acetylene is very unstable, no more than 15. 15 is max. As I told you all before, when I was an apps engineer at Messer, we would cut through 12-inch, 18-inch steel. We'd never be over much more than 10 psi. The O2 is what really cuts through that stuff. What about opening the valve on a fuel gas? Open it slow. How far?
3/4 of the turn.
About 3/4 of a turn and 1.5 turns. Why? Good. That's our oh crap valve. Oh crap, something's going on. I got to turn this off. What about oxygen?
All the way.
How come? A double-seated valve. Fantastic. We talked about pressure on the fuel side, pressure on the O2 side. What determines our pressure on the O2 side? Is that you? Material thickness. Thicker the material, the bigger the tip, the more O2. What about transporting the cylinders? How should we do it? Very carefully. Make sure the cap is on. The cylinder falls with the cap off, and somehow that cap gets damaged, gets sheared off, it turns into a missile. None of us are going to slow down. What else?
Make sure it's properly chained while moving it.
On what? And that's what I'm looking for. But what are we chaining it to? Cart. We got our cart. We chain our tank to the cart. Make sure it's secured. Make sure the cap is on it, and we can move. What about welding on a cylinder? When do we do that?
Never.
Never. Because if we do that, we will die. And that is bad. Never ever weld on a cylinder. What else? I think we're looking pretty good. How about having stuff laying around our area when we're cutting? Book bags, paper, flammables, and 5-gallon gas tank. Get all that stuff out of there. The sparks can travel about 20 feet, and we don't want anything flammable around our work area. Anything else in the shop? No?
Going back to your just tanks in general, make sure to open them slowly. Check
Open them
the
slow.
valves to make sure there's no dust or always dirt in them.
What happens if there's some dirt in there? We hook up the regulator and crank it over.
You mix it with it, cause a fire.
How come?
Because the dirt will basically catch on fire, or it gets hot.
It comes through with so much velocity, it heats up. Like remember I talked about the space shuttle coming in? Heats up because of so much velocity, and if it's O2 or it's not so much pressure on a fuel gas, but O2, it heats up to the point where the O2 can help it combust. Now we've got a bomb. So once again, no good. No mas. Okay. I think we're good on our specific equipment. Now, my favorite part. Our 8 commandments. You guys remember these. Know them. Write them down again if you have to. So as I said, these 8 commandments will help you with any and all welding processes. We got our heat input. As far as gas metal arc welding goes, or flux core, that will be our voltage. Filler deposition, we look at amps or wire feed speed. Our work angle. Now, when we talk about work angle, let me bring this next one up. Work angle and travel angle. We got our part here. Okay. Let's pretend this marker is our torch. We come in. A, is this work angle? Or B, is this work angle? A or B? Okay, we're going to do a 50-50. A is raise your hand. So this is work angle, this is A. Or is this work angle? B. So A is raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Back? Okay. Fantastic answer. Are we A for work angle or B for work angle? A? Perfect. Good. Work angle is a relationship of the torch to the joint. Okay? This way. Travel angle is a relationship of the torch in the direction of travel. What two angles are we looking at for travel angle? Actually, three. We have one way, and another way. We got drag, push, pull. Which one are you supposed to use? Should you use push on the majority of them? When would you use pull? Could be heavy material. What about a perpendicular? Because they're all right. Each one of these is correct. You use whatever technique the place is paying you tells you to use. They say they want you to do a push and a whip and pause, that's what you do. If they tell you to do a drag and run a stringer, that's what you do. If they tell you to hang from your toes and weld upside down perpendicular, that's what you do. Alright? You learn each one of these techniques in our shop. The one that you use is the one that the place is telling you, or paying you, tells you how to use. We can work on that today. I've been working on my toe string, so I can hang up there like a wiener. Okay, contact tip to workpiece distance, or stick out. What's that telling us?
Distance from contact tube to the arc.
Good.
That's along the way.
We're going to break it down even easier than that. From the torch to the material. So if we look at this, where'd my marker go? Close enough. We're looking right here, the distance between the torch and the material. Alright? What happens if we have too much stick out? I heard it's no good. Heat goes down. What do you got? Porosity. How come?
We can't fill up the valves to
Shielding gas.
Shielding gas. If you get too far away, the shielding gas dissipates before it gets to the well. Okay, so the shielding gas does not protect the well. What happens to the amperage as we go back and forth? It goes up and down. If we back up, what happens? It drops. If we get closer, the amperage goes up. Good. Travel speed. It's a tough one. What's travel speed? How fast are we moving? Gas. What's our shielding gas do? Protects the molten well. What shielding gas are we using in the shop? 75-25. What is the most common type of shielding gas? 100% CO2. Good. Real good. Now we have two types of gas when we talk about shielding gas. Give me one. Inert and reactive. What's an inert gas?
Helium.
Helium is an example, but what is it? What specifically is an inert gas? Good, Scott. Doesn't react with other materials. It's a non-reactive gas. Okay, that's the definition I'm looking for, non-reactive gas. What is a reactive gas? It reacts with materials. Okay. Give me an example of a reactive gas.
CO2.
O2. Give me another. CO2. Good. We have helium for a reactive gas. Give me another, a non-reactive gas, an inert gas. Give me another inert gas. Beautiful. And material. Why do we have material in here? Whose phone is that? Turn that thing off. Okay. Why do we have material in there? What difference does the material make in our wells? Dirty or clean? Is it extremely cold? Is it hot? Is it moist? Is it dirty? Does it have grease on it, paint? Is it rusty? Always check your material. So, if we know what each one of these does, we can fix most, if not all, this kind of things. Let's say we had the three that we talked about just a little while ago. We had overlap, undercut, and porosity. Okay, we're welding along, and we see we have undercut. Which of these are we going to look at? Could be travel speed. What would we do with the travel speed? What's that? Slow it down. What's that going to do for us? How's that going to fix overlap? Remember, overlap is gouging in the base material. If we slow down, how's that going to fix it? Gives it more time for the filler to go in there. What'd you say, Eric? And it lets the filler fill in the gouge area a little bit. What else can we do? Up the wire feed speed. What else? Could be work angle. I'm going to go work and travel. You're too extreme and they can make a difference.
I thought it was the other for travel speed because you want it to thin the material out on overlap and on undercut you want it to fill it in, so you want to slow down for undercut and speed up.
Yeah, you're going over undercut or overlap.
I'm
And you're going over undercut, but you just wrote it under the wrong spot.
Sorry about that.
Turn your phone.
I'm checking to make sure you guys are paying attention.
Make sure you don't start.
Okay. So what was the last one we talked about? Traveling angle, wire feed speed, work travel angle, voltage. Voltage, what are we doing with voltage?
Turn it down.
Turn it down. Okay, anything else on here? It could be. What would give us undercut with the material?
Does it have water on it?
Water would probably give us a little bit of porosity. There's another, and you're going to be learning more about this in metal stack. There's another condition that happens to steel, carbon steel, if it's exposed to O2, atmosphere, what can happen?
Are you talking about the mill scale or the rust?
I'll go with both. Mill scale doesn't come from the atmosphere.
Right.
Mill scale comes from the mill, or rust. If the material is rusty, it causes a little bit of undercut. Okay. Okay. Feeling pretty good on undercut. Overlap. We're welding. See we have overlap. What do we do? And before we go any farther, how many of these do we change at one time? One. You change one at a time. Because we go through and you change all of them. Okay, we're going to up the wire speed. We're going to bring the travel speed down. We're going to do whatever to the volts. Then it's way worse. You do a bunch of other things, it's even worse yet. Do one thing at a time and see if that makes a difference. Okay? All right, overlap. What do we do? Let's start with number one. Okay. Filler. Minus wire feed speed, work angle, travel angle. Let's go back to work and travel angle real quick. If we are welding a T-joint, it's a standard T-joint in the 2 position. So we're here, we're in the horizontal position. What should our travel angle be with everything that we've done out there so far? 45. Should be 45 degrees to the joint. I like that too. 45 to the joint because if you're welding vertical up, if you're welding it flat, it should be 45 to the joint. What about our travel angle? Let's say we're doing a push. What should our travel angle be for a push? Maybe on the high end. 10, 15, 20, 30. Not a whole lot. 30 is going to be a lot. But, 10, 15, 20 degrees, somewhere in there. What about if we're doing a track? We're pulling it. What do we got? Same thing. Same thing. Okay. Back to this. We got plus volts, minus wire feed speed, work travel angle. What was your next thing? Increase travel speed. What else? This is good because this really is limited. If you check these, you should be okay. If the material is super thick, you may get a little overlap. If it's contaminated, you may get a little overlap. But these right here, these are good for a second discontinuity there. What about porosity? What's the number one cause of porosity? Lack of gas. Could be lack of, could be too much. How can it be too much? If we're trying to protect the wall from the atmosphere, don't we want more shielding gas around it? Venturi effect. The gas is coming out with such velocity that it'll suck atmospheric air in and shoot the atmospheric air back onto your wall. Okay? And you're not blowing it away, you're just sucking more atmosphere in. What else on here? Dirty material. What about voltage? It could be. We may have to adjust voltage if we're really, really, really hot. We're putting a lot of heat into the part, and we're doing multiple passes, and we get to the end, we get out of there. If the molten pool is still not solidified when we get out of there, it may cause some porosity. It's not likely, but it may. What about our filler? It's not so much wire feed speed, but there's something else I'm looking for here.
Make sure your filler metal's not contaminated.
Make sure the filler metal is not contaminated. Stick out. Good. Anything else? I'll throw angles in there because if you're way too extreme, you may not be covering the weld, but if you're that extreme, you're going to have other issues. Not just porosity, you're going to have other issues that you're going to see way before you see porosity. Okay, how are we doing on this stuff? All pretty easy. We've been practicing this all semester. You're going to go out there and you're going to be thinking about it again today. You're going to get yourself in a position like, man, there's something wrong. What do? You're going to go back through your 8 commandments and say, okay, this is what I have going on. These are the things that could be wrong. Where do I start? What do I do? And all this is machine setup and operator. What can you change as an operator, or what can you change on the machine to fix all this stuff? As I said before, it doesn't matter if it's big, stick, TIG, flux, all this stuff can't help you. So remember this, take this with you. Okay, next slide. Acronyms. We got our guy come bouncing in there. What's GMAW? Hobby. Gas metal art. MIG. Right here. It's the same process, but what does MIG stand for? Metal inert gas, good. What's MAG? Metal active gas. DCEP, MAG. Good, direct current.
Electropositive.
Electropositive, good. What polarity do we use on these machines? Electropositive, good. What's this one? DCEN. Electronegative. Tom, what is REP? Remember, it's a way to remember the two polarities. REP. Anybody remember this one? Anybody want to help Tom out? What's that? It's electropositive. Some of the older machines, the machines you guys are probably going to have to take a well test on when you go take a well test at a company. It may be an old dinosaur machine that has reverse or straight. Remember, we have House of Rep, we have Senate. Reverse is electropositive. Okay? What's SEN?
Electronegative, straight.
Straight is electronegative. Good. Okay. CC. Chris. It has to do with the machine. Constant current. Good. Let's go. Katie, what's CV?
Constant voltage.
Constant voltage. Fantastic. Make sure you know what all these mean. They will all be on the test. More acronyms. What's this one? GTAW. Don't call it GTAW. GTAW. Scott, you got it? Gas, tungsten, argon. We got a slick little picture of high free. TIG. Eric. Tungsten inert gas. Good. How about FCAW? Flux core arc welding. And SMAW. Shielded metal arc. What does the acronym STICK stand for? Stick. Stick welding. SMAW is stick welding. Doing pretty good on these? Feeling okay? You guys stress out about the exam? Yeah, what? We're gonna be okay. We're gonna be good. Okay, summary, we went over safety. We got our 8 commandments, our acronyms and definitions. Next Monday and Tuesday, I told some of you that had a rough time with the midterm, I will have a study group. I'm going Monday, Tuesday because I have a nice block of time after each one of my classes on Monday. Let's go 11:30 on Monday or Tuesday. What works best for you guys? Tuesday? Anybody else? Who wants in on it first? A little better than half the class. Okay. Who wants Tuesday? Hands up. We got 1, 2, 3. Who wants Monday? 2, 3. Looks like we're going Monday and Tuesday. I'll give you guys about 45 minutes or an hour. We'll go talk about what's going to be on the exam, what you had trouble with on the last exam, and we'll get you through your issues and have you ready to take the final. No, we'll do it in the hub. This is way too loud of a group to be in the library. We're manufacturing. We're manufacturing people. We'll go sit in the hub, grab some lunch, and we'll talk about what's going to be on the exam. Okay? That's it. Next week, Wednesday. Remember, Thursday is our exam. Wednesday, we're going to go over the second part of this, which is going to be discontinuities and defects. So those boring videos we watched, where I had to stop and make sure everybody's awake and go over stuff, we're going to be talking about that. The reading we're going to talk about, and we're also going to talk about testing methods. Sound good? Okay. We are 117. Let's go out the shop and start welding. Remember all this stuff? And like I said, don't get too hung up on the exam. Don't worry about getting the last project finished. Worry about today. Don't worry about what's coming. Worry about what's happening right now. All right? Are we ready? Yep. We're going to get after it? Yep. Let's rock.